Okay, so I've started the recording. My name again is Peter Smallidge. I'm the New York State Extension Forester, and I'd like to welcome you all to this presentation on the green lie. Those of you who are participating live can obtain a copy of this presentation as a PDF if you go to the File menu in the upper left-hand corner, go to Save As, and select the document. So if you select the document, be sure to change the file type to a PDF file type, and then you can save that to your desktop or into a folder or whatever you want. So I offer that so in case there's something in the presentation that you want to see, do it now. You can always delete it if you decide you don't want to keep it. So, and why don't we, if we would, please let me know what do we usually do? I guess the county and the state where you're seated right now. So I'm in Essex County, New York. I'm in the eastern part of New York, eastern Adirondacks. If everybody could type that in, send it to all participants. That'll do a couple of things. That will make sure that you know how to use the chat window. So if you are listening and you hear this and you don't see counties and states scrolling in the lower right-hand corner of the screen, then you need to click on the chat icon in the upper right-hand corner. We have a nice distribution, it looks like. Washington and North Carolina and New York and Vermont and Tennessee, so this is great. And we'll go ahead and get started. So this was a presentation that I developed for, I originally developed it for a New York Forest Owners Association annual meeting. It was one that I've been interested in and thinking about for quite some time. And the focus of it is less about the green lie and more about building a framework for vegetation management decisions. And the basis for this is that there's a lot of landowners or foresters that I work with, and you're confronted with a situation, you look at the vegetation, you think about all of the different things that go into making a decision about, should I treat this vegetation? Is there a problem here? Should I treat it? And then what way do I treat it? How do I figure out what treatment is appropriate? So that was what I really wanted to focus on. My goal, and I'll be a spoiler here, my goal was to have a really simple flow chart or dichotomous key or something like that that would spit out the answer at the end. I haven't gotten there, so I've gotten a little ways down that path, and we'll conclude with some screenshots, some pictures, and you all will have a chance to say, type in a message, what would you do in response to this? And from what we can see, there's a lot of different options that people have. So I may never get to the point of a flow chart or a dichotomous key, but we can certainly talk about the things that go into the factor into making this decision. So if we're talking about kind of bad outcomes of forestry, let's talk about good outcomes of forestry. This is what we want to have happen, right? So what are some reasonable outcomes for good forestry? When I think about sustainable forestry, I think about we want to retain the options of the current forest or the current stand into the next stand. And the stand, of course, is the management unit. It's the forestry equivalent of a farmer's field. So a farmer has a hay field or a corn field. We have stand 1 and stand 2. And we want to be able to retain the potential for things like productivity per acre, species diversity, volume production, grade, and things like that. We should be able to have some predictability about how the woodlands respond to what we're going to do. We should be able to recognize, anticipate changes in stand development. So if there's going to be changes over time from an early successional forest to later successional stages. And then, of course, some of these stands, many of them are going to be harvested, and that's certainly fine as long as we continue to work within this notion of of retaining those options and opportunities into the next stand. So, thinking about all of the things that go into this, the New York Forest Owners launched an initiative that has now been adopted by a large number of agencies and NGOs and institutions in New York. It's broadly falls under the Restore New York Woodlands. That's the initiative as NIFOA named it. In New York, this coalition thinks of it more about as the third growth forest, making sure that we can regenerate and reproduce the next stand. And we can have success in that when we reduce deer impacts, when we manage and provide for sustainable harvesting, and when we control interfering vegetation. So the overlap of those three needs should result in our ability to regenerate the next forest. And we want a forest that's healthy and productive and diverse. And we have some good examples of that. We have examples where the forest is regenerated, especially where we've had regeneration that gets above the height of deer browsing. But then we also have a lot of examples where we have interfering vegetation or heavy browsing by deer or things like that. So, you know, it's one thing to show pictures. It's another thing to have some data to back that up. So a few years ago, there were two projects. One of them was launched by the Nature Conservancy in New York, and you can see the citation here, and that publication is also available on the NIFOA, nyfoa.org website if somebody wants to see it. And what they found was when they were looking at FIA plot data, so these were plots from the U.S. Forest Service, and they were looking at the regeneration layer, and they created an index. The Nature Conservancy created an index where they evaluated the probability, the potential for plots, percentages of area within New York State to regenerate. And the pie chart on the left is looking at all canopy species, so that includes all canopy species. And on the right, it includes timber species, so it includes species such as American beech. What they found when they looked just at the timber species, that the percentage of regeneration was less than half. It was 43% was rated as good or very good. So this is kind of concerning. And it aligned, coincidentally, very well with work that we had done when we surveyed foresters. So this was a Human Dimensions project where we sent a mailing out to foresters in New York, and we asked them to reflect on a stand that they had recently visited that had been harvested in a way that it should regenerate, and we gave them parameters for how we defined successful regeneration. And statewide, we came up with 30% were in that successful, highly successful, or moderately successful range. So we were at 30%. The Nature Conservancy was at 43%. So those didn't line up perfectly, which you wouldn't expect. But the end result, if you look at the average or however you want to consider it, is not looking very good for the capacity of New York forests to regenerate in a way that we want them to regenerate. We had, in the study that we did with foresters, we had a slightly more rigorous definition of what constituted successful regeneration, which is probably why we had less success in attaining successful regeneration. So what's behind all this? You know, what are the barriers to regeneration? We asked the foresters to identify that, and what we found was that statewide, not surprisingly, deer showed up as the most common factor in causing marginal or failed regeneration. Statewide, it happened 65% of the time. It varied throughout the state. In the Adirondacks, it tended to be less. In the Southern Highlands, it was pretty close to average. And then other were areas that we didn't have enough data points in, but that included the Lake Plain along Lake Ontario and then the lower Hudson Valley. So deer pressure was extremely high. So statewide, 45%. The second factor was interfering vegetation. And interestingly, that was fairly stable across the state. So just shy of 50% of the foresters felt that interfering vegetation was limiting the regeneration of the stand that they were thinking about. So regeneration is an issue, and the two biggest factors are deer and interfering vegetation. And interestingly, there's been some some work that has gone on to support that deer are in large part a driving force in much of this. And the interfering vegetation, whatever it's caused by, creates something that's referred to as the green lie. And I've heard about the green lie, the label, the moniker, the green lie for many years. And I finally, from Dr. Nyland at SUNY ESF, shared where he had heard that originally from David Cook, who was a DEC forester back in the a few decades ago with the State Forestry Agency. And basically, and I don't know exactly how the green lie is stated, the way I understand it is that essentially if the forest has green plants, then all is well. The lie is that this presumes that all plants are created equal. And so you can look at the picture and you can say that's a forest or it's a woodland and it's green, so everything must be okay. But many of you can look at that picture and say, well, but it's 100% beech. So that's a picture of a beech forest. Now, that, by some standards or by some objectives, that may be okay. The green lie can happen at two levels. We can have a green lie that happens at the level of the canopy because unsustainable harvesting, exploitive harvesting have removed the high-value trees and left behind low-value trees. And it may be low-value stems, so good species, but of poor form, or it may be low-value species, removal of the higher-value species. So we can have a kind of an upper-level green lie. What I'm focusing on today is this lower-level green lie, where cutting practices in New York and throughout much of the eastern U.S. favor selective harvesting, exploitive harvesting, so cherry picking, so to speak, no pun intended. A few trees per acre creates enough sunlight to favor the growth of shade-tolerant, browse-resistant species in the understory, and that understory dominates and can interfere with the ability of the next forest to regenerate. So that's a problem, right? And it's a lie for people who don't understand differences between species because they look at the forest and they think everything is well. And there are several examples, anecdotes that I've heard through trained volunteers that work with Cornell Cooperative Extension who have been out to visit with other landowners to help connect them to educational resources, and these landowners assume that they have a woodland, and because it's green and there's going to be some timber revenue in the future, and the trained volunteers look at it and say, well, things aren't going to go the way you think they're going to go. So the other consideration is that as I started to mention, deer are often a driving force. So if deer are eating, the forest may be regenerating, but if the deer are eating the desirable canopy species, they're preferentially favoring, because through avoidance, they're favoring the non-palatable interfering vegetation. Research, though, has documented that even if we remove the deer, in many cases, we still will retain this stable plant community in the understory that's dominated by undesirable species. And that's a legacy effect. And so even if deer are a primary force in these ecosystems, removing the deer doesn't obviate the need for us to attend to plant problems. So the plants that we're talking about, and I'm using the word interfering, because it encompasses both native and non-native plants. And so you have two lists up here, native interfering vegetation and non-native or invasive interfering vegetation. In New York, and I presume in other states, there is a legal definition for what's invasive, and in New York it has two components to it. It includes a component that it needs to be non-native, and the state has been I'll say flexible in what they consider to be native, and whether it's native to North America, native to the United States, or native to New York. But however it's selected, it's non-native at some level, and then it also has to essentially do more harm than good. So there are some plants that are non-native, like corn and like apples, that have very important economic benefits to the people of the state of New York. There are other species like European buckthorn and multiflora rose that may have some very minor economic benefits, but their detriment outweighs their advantages. Because it's not really relevant to us whether or not, when we're selecting treatments, whether or not a plant species is native or non-native, I use the term interfering because it encompasses all of these. Some of the common botanical features of interfering plants is that they tend to be shade tolerant, but they can respond fairly quickly to low-level increases in light. They have very high reproductive success. They have good reproduction often from seed as well as vegetatively. And vegetatively, they may sprout from the stump or from the root. And some of them will form a seed bank, and some of them will form a seedling bank. So they're basically good at what they do. They also all share the common feature of not being palatable for deer. If they were palatable to deer, then they wouldn't be there. So Scott has a question, and yes, please, as you have questions, please pump those in there. Type them into the chat window. So the color codes refer to the black are trees. I'll call that purple. It may not be purple. The purple are shrubs. The green are vines. And then the blue are herbaceous plants. So good question. Thank you, Scott, for asking that. Okay, finishing up here, all of these undesirable plants have the ability to form dense, stable monocultures, and that's largely because of the conditions that I mentioned before. They're tolerant to the shade. They can grow in full sunlight. You've seen many of those plants listed, especially the shrubs, dominating in abandoned agricultural fields, dominating in power utility rights-of-ways. So they can grow in full sunlight. They can also tolerate shade. They have higher reproductive output. They're not palatable deer, and as a result of that, once they get established, they're good at what they do. They form these dense monocultures. And then they have the ability through a number of mechanisms we'll look at in just a minute, the ability to inhibit the regeneration of native desirable plants. So Kathy's asking why American beech is undesirable. We'll come to that later in the presentation, so I'll save that if I can. So, okay, so how is it? What are their mechanisms that they use to inhibit regeneration? There are 4 basic mechanisms, 5 mechanisms. The first 2 are maybe rather obvious. The first is obvious, is light quantity, the amount of light that's available. So there's this layer of shade when you have this. So you think about the upper canopy, the trees have a canopy, and that's, I think about it like as a tarp, a suspended tarp that might be 50 or 60 or 80 feet above the ground. And that blocks some amount of sunlight. If it's a tarp, it would block all of it. But as that tarp comes down, there's another layer or canopy that might be a mid-canopy layer or a shrub canopy layer. So you have another tarp that occurs at 6 to 15 feet, depending upon the plant species, or maybe a tarp or a canopy that's at knee height or waist height with some of the ferns or with garlic mustard. So that interferes with, just physically blocks the quantity of light that comes in. A second mechanism is the quality of light. This tarp selectively captures some wavelengths of light. The red wavelength is most useful to plants. It has the highest energy. Some of that is captured in the upper canopy. So if we have good trees in the upper canopy and it's capturing those wavelengths, that's okay because those trees are benefiting and we want them to benefit. As we manipulate the forest to try and regenerate the forest, we're reallocating where those red wavelengths go, and we're trying to get those red wavelengths to the forest floor where they can benefit desirable seedlings. If those red wavelengths are captured as they pass through the vertical profile of the forest by other plant species, undesirable plant species, they preferentially take the red wavelengths, but the far red wavelengths continue on. Those far red wavelengths, especially as a ratio relative to the red wavelengths, limit things like the germination of seeds and the growth and development of seedlings. So the quality of light matters as well. Many of these interfering plants form a physical barrier. The best example of that is what ferns do. So ferns have, of course, the shading element of their canopy, but they have a very dense root layer. So if you haven't tried this or you haven't seen it, go out into a fern field with a shovel and dig down through that root layer. It's a significant physical barrier to the ability of seedlings to push their first root, that radical, down through that mat. There's altered habitat for seed predators. This is, and I've listed in here the species that tend to be particularly sensitive to these different mechanisms. Whether it's barberry or ferns, it's a dense layer where rodents can occur and are particularly protected from predators of rodents, and then they become more effective predators of seeds. And then finally, changes in soil quality, and there's been some work done with garlic mustard where it's changed soil mycorrhizal relationships and limited the ability of other species to establish. So we have these plants, we have these lists of plants. We know there are some mechanisms, but before we really start, jumping in and thinking about, okay, we need to manage some plants. It's worthwhile, as you approach a problem or think about a problem, think about it from what's the target. And this is a concept that was made clear to me just last week, and the best analogy, I think, is if you've looked at or thought about pathogens of forest. We talk about primary pathogens and secondary pathogens, and oftentimes we look at a tree and that tree is diseased or sick or it's declining, and we see some organism, whether it's a fungus or an insect, and because we see it, we assume that that insect that we see is the cause of the problem, is the root of the problem, when in fact it's responding to the reduced stress of that tree, and the real cause of the problem may no longer be apparent. The same pattern exists when we think about interfering species, and particularly interfering plant species. And we have pests or interfering plants that may function as drivers, but in other cases they're more like a passenger. So they're a primary pest or a secondary pest would be some other language or terminology we could use. So in many cases, the primary pest is really deer. And so we can go in and we can make huge investments of time and money and labor and resources in controlling a plant pest problem. Say that once slowly. And if we haven't controlled the primary pest, which in some cases is deer, then we haven't really gained much. And so as we're moving now into some of the strategies, having built the foundation or the context for this problem, keep in mind that we need to not only control the immediate, approximate issue or the approximate interfering pest, but also the primary pest. So the word then to the wise is don't rush into a situation, right? People say, well, the early bird gets the worm. Well, the first mouse does not get the cheese. So the admonition here is to not rush in, but to be deliberate and to think about how we want to approach this problem. The structure for thinking about how to approach this problem uses a framework known as integrated vegetation management or forest vegetation management. And the goal is to find an efficient, cost-effective, and ecologically appropriate control of undesirable plants, but enhancing the population of desirable plants. So that second clause, enhancing the populations of desirable plants, assumes that if there's a driver, if there's a problem, an interfering pest that may not be immediately apparent, that needs to be identified, or you will never be able. You may control the undesirable plants, but you will not be able to establish the desirable plants. So you have to profile this. each individual problem, and there's 5 steps that you would go through. The most important is knowing what the biology of the plant is, which starts with identification, making sure that you're not controlling a plant that looks like an undesirable plant. Thinking about the extent of the problem. Are you dealing with 1/4 of an acre or 10 acres or 100 acres? How much control do you want? And certainly as the size, the extent of the problem increases, the ability to have 100% control declines. In most cases, it's not feasible to have 100% control. There may be, I have on my property, I have a 1 acre clear cut that I put in about 10 years ago, and I was down there this spring and I found 6 bush honeysuckles. And so if we assume that I found all of them that existed, then I can say I had 100% control. But in reality, I'm sure there's some that I missed. And if those 6 are there, there's a seed source somewhere. And so I'm sure that I have not achieved 100% control. And the objective is probably to obtain 100% control is probably not going to happen. We need to look at the costs for each tool that we decide or each treatment that we come up with. And there's the direct costs. So if you use, so when I was controlling the bush honeysuckle, I had a pair of hand clippers and a little hand saw and a little squirt bottle with glyphosate. And so there's a cost to those tools. There's a cost for my time, but there's also a cost for me to not treat those. Or if I treated them ineffectively, the cost would be that they may have produced seeds and complicated my management options into the future. So there's a variety of costs. And there's also, it's important to note that every one of these treatments has some cost associated with injury to the humans involved. And it may be collateral damage if we use herbicides and we use them ineffectively. There may be environmental costs and human costs there. If we ask people or we ourselves use machinery and we don't use it correctly and we're injured, then there's a human cost there. And then finally, the profile that we develop for all of our treatments should consider what's going to be growing there after we make some level of control on the undesirable plant species. So as you're looking at a particular problem, there's many questions you'll want to consider. First of these is whether you're reacting without a purpose or a plan. This is a tendency when, it's easy to go out and give presentations and get a lot of kind of energy going about bad plants or interfering plants, and people see that they have them on their property and their inclination is to go out and just jump in and start attacking them. But that's not necessarily an appropriate strategy. That I just remind you of that mouse. The first mouse doesn't get the cheese. So it's good to think about controlling interfering plants, but do it with a purpose and have a plan in place. And I add in, we need to make sure we know what that driver is. It's also worth asking the question, what happens if you don't take any action? Just because you have a plant that you don't want doesn't mean that you necessarily have to take any immediate action. The bush honeysuckle that I had was a good example. Bush honeysuckle doesn't really develop fruit until it's 4 or 5 or 6 years old. So if I see it, usually if I see it in small, then I'll just pull it up. But if I miss it, it's not the end of the world, and I have a couple of years. And so if I have some small plants around, it's not essential that I go out and take action. And it may be that you have, it may be that you're embedded in a landscape where you have you're almost overwhelmed by interfering plants, and it's not feasible to think about going out and treating all of these areas. And so there are some areas where you don't take action. There are other areas that you prioritize because you're going to try to regenerate them, or you have some ownership objective that warrants attention on a particular area. You need to look and see if there are other desirable species present. This is going to significantly impact which treatment methods you use and whether deer are causing a problem. Deer would be one of those drivers. And then think about what control methods are going to be effective and how much are they going to cost. So those are all several questions. that have to come into play. And as you're thinking through those questions, you're going to arrange those into one or more squares of this matrix. So this is an overview of management options with examples of method and mode. So everything that you decide to use is going to have be able to assign it to a method and a mode. And it's important to note that you can mix and match these. So, and I'll come back to that. Under method, we have two methods. We can use either mechanical methods or chemical methods. And so mechanical methods are going to be organic. Chemical methods will not be organic. And then under mode, we have broadcast or selective. And this is how our ability to the specificity we have in hitting the target. So if it's selective, that means we can identify an individual plant and treat that individual plant. If it's broadcast, that means we say, here's this tool that I'm using, whether it's a mower or a sprayer or livestock, and I'm going to apply this tool to this entire area, and everything that's within the bounds of this area is going to be impacted. So obviously, when you have a broadcast treatment, you would only do that in areas where you have few or no desirable plant species, and so your collateral damage is going to be very small. So let's look. I've given you some examples here. Just MIG is management intensive grazing, but let's look at some specific examples of this. So management intensive grazing is like rotational grazing. So let's look at examples. Broadcast mechanical. Goats, if put in a high enough density, can achieve management intensive grazing or rotational grazing. Goats are an example, sheep are an example, horses or cattle. So turkeys, I used turkeys one year to control some ferns, and they weren't really grazing, that was more of a trampling response. But anyway, you use livestock as a tool. And under high densities, livestock, which tend to be selective browsers or selective grazers under very high density, will be broadcast, and they will hit all plant species. And then we have examples of things like there's a whole suite of different types of all-terrain mowers. This is a Fecon. I'll give some examples of that later on. And this is what it looks like. So this is before a Fecon. This is after a Fecon. So this is broadcast mechanical. Broadcast chemical, use different types of either ground-based machines or backpack mist blowers or spray pumps to use typically glyphosate-based products, so Roundup type products that are sprayed to control foliage. So these are mostly foliar sprays, very low concentrations, 1 or 2% active ingredients. We have selective mechanical, things like flame weeding, things like girdling. For those of you that have done some girdling, you will note that there's this strip of, let's see if I can do it here. Where's my pen? So there's this strip of tissue right here that is, was not cut, and so that tree will remain alive. So if you're going to use a tool, the message here is that you need to use the tool correctly. And then things like just mulch is a selective, that's probably broadcast, right? So any plants that were inside the zone of that mulch was going to be impacted. So that's really a small scale broadcast mechanical, but I think you get the idea. And then finally, selective chemical and things like drill and fill or hack and squirt or basal bark. So those are all selective chemical. And so you get the idea. So selective means you pick a plant, and then broadcast means you pick an area and you treat the area. So we're talking about chemicals and the use of pesticides, so I want to take just a minute to give a pesticide disclaimer and also some terminology. So a pesticide is the broad term. Pesticide, side is to kill, like homicide, you kill humans. Pesticide is you kill pests. So all all of the chemicals that are used in forestry treatments, agricultural treatments fall under this broad heading of pesticides. Herbicides are a type of pesticide. Herbicides are used to treat plants or to kill plants or to regulate the growth of plants. We have insecticides, are a type of pesticide that control insects. Fungicides are a type of pesticide that control fungi. So you get the idea. The U.S. Environmental Protection Agency approves labels or regulates the development of pesticides, and they delegate authority to that in that regulatory function to state agencies. In New York, it's the New York State DEC, Bureau of Pesticide Management. So every state has a state agency that is delegated authority by the U.S. EPA. An important part of that regulatory capacity is that every pesticide has a label, and a label is a written statement that's attached to the container, and it's an important and very useful document. So first, on the legal side, is that when you use a pesticide, at least this applies certainly in New York, and it may apply in other states, when you use that pesticide and it has a label that has an EPA registration number on the canister, there's a label somewhere. And when you use it, it's presupposed that you are agreeing to the use to follow the guidelines of that label as if you had signed a contract with the state or federal government. So you would never sign a contract without reading the contract. So if the label is effectively a contract, it's in your very best interest to read that contract or that label and make sure that you follow it. So that's the legal spin on it, if you will. The positive spin is that there's very useful information. Most importantly, it tells you what personal protective equipment you need to have as a minimum in order to use that product. So do you need to have nitrile gloves? And if they need to be, 4 mil or 6 mil or 16 mil, you know whether you need to put on one pair of nitrile gloves or 2 pairs of nitrile gloves. It lets you know whether you use safety glasses, breathing apparatus, Tyvek suit, whatever it is. And the label will give you the minimum standard for that personal protective equipment. The final point I want to make here is don't use home remedies. You've all heard of these, and people always have some kind of a concoction that they recommend that they think will work. When you ask people, why to use a home remedy, why don't you go, purchase a product if you're going to use a product that's in the form of a pesticide, why don't you purchase one that has proven abilities? And the response is often either they don't want to spend the money, which is many of these products are relatively inexpensive, or what they say is they don't want to put chemicals into the environment, which is kind of curious because almost all the home remedies that I hear about always involve diesel fuel. So people are putting, even with the home remedies, they're putting some kind of a chemical into the environment. The difference is they don't have any idea what chemistry constitutes that product or the impacts of that product in the environment. The first website that you see there, the Penn State University, is a great website. Dave Jackson and Jim Finley run that. It's the Forest Vegetation Management. There's a lot of information there about a variety of forest vegetation management. Cornell, on behalf of the New York State DEC, has what we call our PIMS site, and every state has this. It's where you can go to look at a label. In New York, this is the site you would go if you want to purchase Weed Be Gone, or you want to purchase Rodeo, or you want to purchase Garlon 4. You can go look at a label online before you make that purchase. Okay, so we know the framework, the method and mode. We know some examples we can be thinking about. We've covered the pesticide disclaimer. Where we want to go, where I want to go with this presentation, is to say, well, let's look at this framework for making decisions. Which of these, or which combination of these factors, methods and modes, should we pick? Before we get into that, there's some things about selective modes that are worth mentioning. This applies both to mechanical or chemical methods. First of all, selective is going to be most useful where you have a low density of stems, a low number per acre. There's not good research that gives us what that threshold is. Previous research has suggested somewhere around 400 stems per acre is going to be an economic threshold. Now, there may be other thresholds. If you have a high proportion of desirable stems mixed in, you may be willing to incur greater economic cost, let's say, and bump up the physical number to 600 or 800 stems per acre, but that becomes very tedious and very time consuming. But anyway, just be conscious of the fact that the stem density is relevant, and that it's going to interact with the presence of desired species. It may be that you have large stems like this beech tree that is being treated by hack and squirt, and that's going to call for a selective treatment. It may be that all you have are access to selective equipment, like a hatchet and a squirt bottle, and so therefore you're limited to selective equipment. So Kathy says the labels tell us how quickly they break down, collateral damage. The label does not tell you that, but there is other information, usually on websites, that will give you that information. The Penn State website that I just showed you has a book on using something like use of forest herbicides or something like that, and they talk about the half-life. So there are material safety data sheets, and there's other information. If you do a Google search for glyphosate or for rodeo or for triclopyr, you can get information about that, about the breakdown. In terms of the collateral damage, that's in large part how you actually apply it. So here we're looking at selective. Selective mode is going to have less collateral damage than a broadcast mode would, typically. But also the product that you use. So products like glyphosate have no soil activity. Glyphosate is the active ingredient in Roundup, and that whole kind of family of Roundup-related products, rodeo and Accord. It has no soil activity, and when it gets in the soil, it binds to soil organic matter. There are other herbicides that do not bind to soil organic matter and have soil activity, so they can move in the soil and have collateral damage to other plants. So those are things that you need to evaluate before you make a selection. Okay, let's keep going here. I'm not quite halfway through, and I'm way beyond the halfway point. So broadcast is going to be useful where you have high stem density. Maybe you have a moderate density, but the plants are painful, and multiflora rose and barberry, as pictured, are two examples of that. It may be that you have an area such as a steep slope that's difficult to access on a plant-by-plant basis, and so you need to use a broadcast treatment. Or it may be that phenology provides you a window. So there may be in August, it may be that you have a mixture of desirable and undesirable plants, but if you go out in late April, you're working largely maybe with non-native plants such as bush honeysuckle or multiflora rose, and those leaf out prior to the native plants. You can do a broadcast treatment early in the year because the phenology or the seasonal expression of those plants provides you that window of opportunity. You should avoid, or at least consider avoiding, mechanical methods with plants that sprout aggressively. So I have pictured here Tree of Heaven. That's one of those plants that sprouts from the stump and sprouts from the roots. And can you treat it mechanically? Yes, but it's going to require repeated cutting. So these are trade-offs, and it's not, just so you know, it's not my job to tell you that you should use mechanical or that you should use chemical, but rather to help provide information that you all can use to make a decision about what you want to use. And also can reconsider mechanical methods, especially for sprouting plants, if there's a need for definitive control. Now, there are occasions when you can use mechanical methods even when you want to have definitive control. You should reconsider or avoid chemical methods if there's some unacceptable risk of direct contact, for example, overspray. If there's a risk of indirect contact, so they're volatile organic compounds. And the best example of that was a site that I visited, and it had been treated similarly to this picture. That's a picture of me doing a basal bark treatment on American beech. And the treatment was also basal bark on American beech, but it was a much smaller average diameter. There were hundreds of stems per acre. What happens with this basal bark, which uses Garlon 4, and the active ingredient is triclopyr, is that chemical will volatilize, so it turns into a vapor. And when it did, in the heat of the summer, it volatilized, and the sugar maple was a canopy, mature sugar maple canopy over the American beech, and it trapped those fumes and it killed the lower branches of those sugar maple trees. So it was kind of an interesting play on that treatment. But it calls to mind both whether or not you should use certain chemicals and the conditions under which you would use those. Also reconsider mechanical methods, chemical methods, if there's sensitivity to different environmental circumstances, if there's a constraint of the property. In some watersheds they don't allow the use of chemicals, or if the season that you're going to apply it would limit it. So there's some chemistry that you don't want to use in winter or during wet weather or things like that. So those have to be taken into consideration. Okay, so now let's look. We've provided a context. We've thought about our different strategies and how we can configure those different strategies. Let's think about the parameters that influence our decision making. The first of these is what the owner has for objectives. And this, when I think about woodlot management, this almost always is the driving factor. So the owner who owns the property has vested interest in it and rights to that property, needs to decide the desired outcome, what constraints they have on treatments. Constraints would be things like the tools that they have available, the time that they have available, and the money that they have available, and then what they want as a future plant community. So depending upon how a landowner responds to these different components, that may dictate the types of treatment that are applied. A second consideration is the biology of the plant. So you look at the life history, the species life history. You see pictured striped maple. Striped maple is a native species. It's kind of pretty, but it has an ability to produce large quantities of seed. It has the ability to flip from a male plant to a female plant under stress to pump out large numbers of seeds. It'll sprout vegetatively from the stump. It'll form a seedling bank. It does not form a seed bank. But so every species, this is just an example of striped maple, every species has characteristics that you need to know about in order to pick correctly the treatment options. And at the same time, when you're thinking about the plant biology of the target species, think about the plant biology of non-target or desired species that are either present or you would like to be present. The third factor is whether there are limitations on the use of herbicides. And as I see it, there's kind of two components to this. One is that there are some landowners who are not willing to use herbicides, and that's fine. There are almost always other ways to control interfering plants. It may take, it may require greater effort or greater cost, but there are ways to work around the use of herbicides. So if they're not willing or if they're not able. So there are some maple producers who are organic, and because of that, they're not able to use herbicides to control undesirable vegetation. And there are some watershed restrictions. So the watershed for Boston, the Quabbin Reservoir, does not allow, for example, any use of herbicides. So those are a couple of examples of where you would need to find mechanical organic methods. So when I think about what are the kind of the rigid constraints, I put those two as the rigid constraints. So we have plant biology and whether or not sprouting is, specifically whether or not sprouting from the roots or sprouting from the stump is a concern in the short term. And then whether or not it's possible to use herbicides. So yes or no. So this again, two-way matrix of yes, no, dictates where you would go in terms of the types of treatments that would be considered for use. So let's say that yes, sprouting is a concern, but yes, it's reasonable, it's possible to use herbicides, then there's a whole kind of series of thinking where we would like go to A. So this was as far as I got with my flow chart, or my dichotomous key, was to look at these two variables. As we look down through these 10 factors, you get the sense that there's probably it'll be hard for me to get beyond this kind of 2x2 matrix. Okay, the fourth parameter we want to look at is the duration of impact. So how long do we want to be able to have an influence on the vegetation that we're trying to control? It may be that we're installing some maple tubing and we have a need to control it for one season. So if that's the case, and depending upon the biology of the plants, we could go in with a brush saw and cut paths in order to put that maple tubing in. It may be that we want to establish some regeneration, and we think that we have 5 years, a 5-year window over which that we'll be able to establish plants and get them up and growing, whether we're planting them as you see pictured or doing it through natural regeneration. And it may be that we're trying to, we have a different forest regeneration situation, and we think that it's going to take us longer to get those plants established, and we need 10 years of control. And it may not be that we do one treatment and it has 10 years of control, but it may be that we have a plan that says we're going to treat it really aggressively in year 1, and then we'll do lower intensity treatments in year 3 and year 6, or something like that. So the duration of impact. It may be that we either want to include or not include multiple treatments. So with multiple treatments, if we can do like multiple entries or 2 different treatments at once, we can do things like a mechanical treatment that then we follow up with a lower intensity herbicide treatment. We'll talk about that, but many times that gives us much better control with greatly reduced collateral damage. But it also carries with it perhaps some added financial costs, because if you do these as 2 separate entries, then you have labor occurring twice. There's an opportunity cost potentially because if you're using equipment, there may be damage to non-target plants because of the equipment. There may be damage or consequences, I shouldn't say damage, there may be consequences of soil disturbance. And it could be a good thing because you enhance seedbed. It may be a bad thing because you enhance the seedbed. So this is where we know, where we want to know what's the next plant community that's going to come in here. If we're going to do, if we're going to work with livestock and we want to establish forage plants, and those, we're going to have a dense sward of forage plants that would outcompete undesirable plants, then soil disturbance, such as we see, well, this is the business end of a fecon. That's a good thing. It may be that we have concerns about garlic mustard and a lot of seed, and then if we disturb the soil, then we're going to just create, maybe we're controlling one plant, we're going to aggravate the situation with a second, more problematic, undesirable plant. So it's not good or bad, it's just think about the consequences of soil disturbance. Whether or not we're using chemical or mechanical, we need to worry about soil disturbance with ruts from machines. And similarly, proximity to water table is important if we have herbicides that are active, that are mobile and active in the soil, then we need to be sensitive to that. And in New York, many herbicides are restricted, for example, against use on Long Island because of shallow water tables in those areas. We may want to integrate mechanical and chemical. This might involve multiple entries, and so this is what's called a cut stump treatment of American beech. And I've not forgotten that we need to explain why American beech may need to be controlled. So we cut it and so we have a mechanical selective cutting and then a chemical selective treatment. So that integration is oftentimes very effective and provides greater success in what we're trying to accomplish. Number 9 is spatial patterns of control. It may be that we want to make controls in very deliberate patterns. So it may be a block, it may be a linear corridor such as you see here, it may be linear associated with tubing systems for maple, whatever it is. It may be that there's a pattern to the desirable vegetation. We need to avoid that. So it's either we're targeting to hit an undesirable plants, or we're targeting to avoid hitting desirable plants. And then finally, considering the equipment that's available. So it may be that you as a landowner, or your consulting forest or industrial forester or service forester working with landowners that have certain types of equipment. They maybe just have a chainsaw, or they have a tractor with a brush hog. Maybe there are physical limitations to the types of equipment that they can use, or that they're willing to use. Or maybe they have a relationship with a neighbor that has equipment that they can use. So all of these, the equipment availability is a concern. That's less of a concern with vegetation contractors, because they would probably have access to a full suite of equipment that they would want to work with. So that's the list, right? So the starting point really is thinking about, the two, what I call the rigid constraints are plant biology and whether or not it's possible to use, it's feasible or practical to use herbicides. And then there are these other factors that come into play. So what I'd like to do now is show you some examples of problem plants and give you a minute to think about, if you saw that and you were confronted with that, how would you deal with it? And then you can type in some responses if you want to, or just, it'll be more fun if a few people type some responses in, but at least think about it. So here we have kind of a immature forest, woodlot, average diameter of trees. It's a hardwood area, some oak and some hickory, maybe a little bit of red maple. Average diameter is 10 or 12 inches. And there's a very solid understory of autumn olive, rose, and bush honeysuckle. What would you do? Okay, so Dana offers an option. Who else has some ideas? All right. So we have some mechanical as well as chemical, and both those are also on my list. So here, I came up with 6 different ways that we might treat that. And depending upon the circumstances, any 1 or 2 of these might be good, or in other circumstances, those 1 or 2 might not be so appropriate. So Dave Jackson, hey Dave. All right, so Dave and I agreed here. So we have fecon is an option. So we saw the fecon, and you'll chop it up, and then as it resprouts or you establish some plants, you'd put in livestock. So we have broadcast mechanical followed by broadcast mechanical. It may be that you use a fecon. Some of it's going to sprout, give it a year to sprout, and then go back and do a spot foliar. So that might be broadcast mechanical and then some combination of broadcast or selective chemical. It could be that you just go into that whole area and use a mist blower. So you walk around, or you bring in a machine and do a ground-based spray. So you do a mist blower. It's fairly dense, so you'd want to do a fairly hot mixture, probably of glyphosate, one of the glyphosate products. Could be with a brush saw, stump treatment, 15%, or something fairly hot, so selective mechanical followed by selective chemical. It could be that you just do fecon and come back every few years to do fecon again. This would be fairly expensive but doable if you wanted to be strictly organic and you had a large area, or you may, if it's a small area, then you could go in and hand pull it. So you can see there are lots of options. All right, so let's jump ahead. We're at 1 o'clock. I'm going to jump around a little bit. I want to make sure we talk about beech. So the problem with beech is a great species, and so all of you had some good ideas. Okay, so we'll come back to the deer in just a minute. But I want to hit on beech. So beech is a great species. It's a native species. It has a large number of very redeeming qualities. It's a hardwood, has a fairly attractive grain. It's decent to work with. The old butcher blocks, the vertical column butcher blocks, were often made out of beech. The problem with beech, if you will, is kind of a two-phase thing. One is that there are two invasive organisms: an insect, a scale insect, that's followed by a fungus that causes this pattern on beech. And so when beech is attacked like this, and over 99% of the genetics of beech tend to be susceptible to this beech bark disease or beech bark decline, the tree dies. When the tree dies, it forms root suckers, and that's what you see in the background. So you can get dense thickets of American beech, and part of the reason why you get these dense thickets is because in these areas, deer will often eat the desirable plants. They will not eat the beech because there's no nutritional value in beech, and what results then is a beech thicket. And so the problem is, if you have healthy beech, beech is not a problem. If you have areas where you have high preponderances, you have a lot of beech, if you have 1 or 2 beech per acre, beech is not a problem. There are some places where you have forests or woodlots that are dominated by beech, and those beech tend to be susceptible to beech bark disease. So that's the bad news. The good news is you can work really, really, really hard, and you're never going to eliminate beech. So, and I have other webinars just about managing beech, and there's a fact sheet on the Forest Connect site about managing beech. So I'll call your attention to those. So if this is your problem, what would you do? All right. So there's one option: cut them down. Any other management options people want to consider? All right, very good. So we have several options there. So one option is to cut them all down. So you could do that. You could use a chainsaw and cut the bigger trees, and a brush saw and cut the smaller trees. If you did that, so there's some research suggestions that if you cut 100% of the beech, and this is 100%, not like 99.9%, but 100% of the beech, and you low stump them, that you will control the beech. That's going to take a fair amount of effort, but it's an option, especially, well, it's a research option at this point. So you guys have lots of good ideas here. They're scrolling past me. So cut them down. It could be that you cut them. If you tried to spray this, there's probably about 100% American beech in this head-high zone. So if you sprayed them, there's going to be relatively little collateral damage. And the collateral damage that you had would be inconsequential in the sense that if you didn't take action, those 1 or 2 seedlings per acre are not going to survive. So you could do a high level, kind of a shoulder high spray, or you could do go in with your brush saw all of these smaller stems, let them sprout back, and when they're low, 10 or 12 or 14 inches high, come in and spot spray them. You could basal bark these smaller ones. It looks like there's a lot of these smaller ones, but that's possible. You could also, another option I see is to cut this bigger tree, assuming this bigger tree is still alive, cut this bigger tree, cut the stump, apply glyphosate to the outer 2 inches at a high concentration, greater than 25% active ingredient. It pulls it into the root system, and you'll get control then of these smaller suckers if they're connected to the same root system. So anyway, so you get the idea. And there's lots of options. Ralph says, find the resistant beech and save them. Indeed. And actually, this picture was taken from an area where we're having a timber sale. It's a 30-acre timber sale. We found most of the beech look like this. We found 2 beech trees that were perfectly clean. So we've marked those as seed trees. We'll retain those when we do herbicide. So the rest of the areas will do some kind of herbicide treatments. We'll avoid those areas where we have the healthy beech trees. And then probably after the timber sale, and we've controlled the beech around the diseased beech in the area, we'll probably go in and cut those healthy beech so that we can reproduce them vegetatively, so we can make sure that we can retain that genetic base and proliferate that genetic base in that stand. Okay, I want to give one last example. So this is your sugar bush, and you have this sea of ferns. What would you do? Any ideas? Oh, somebody's got to have an idea. All right. Here's what I thought of. So the first thing is to ask the question, is it organic? So if this is a maple producer, and that maple producer is organic, then that takes the chemistry off the table, right? So if it's organic, there's been some research, and this was research that was done in the Quabbin Reservoir, the watershed for the city of Boston, and they did some combination of mowing or weed whacking twice a year for 2 years. So this is kind of a broadcast mechanical, and that had, I'll say, relatively poor success, something like 40% control a year later. So that's an option. Mechanical, organic is an option, but it involves a fairly high input of labor. You could go in and use something like a backpack mist blower or ground-based mist blower with glyphosate, so the Roundup family. Mix in oust, so a broadcast chemical treatment. The glyphosate takes out the foliar. The oust is a soil active and limits the resprouting from the root system or from seeds. It might be that you would follow up one or both of those treatments with a frost-sensitive forage crop, and I don't have any examples off the top of my head. I went to a workshop, and I've never tried this, so this is, number 3 here is me speculating wildly. But I went to an NRCS workshop a few years ago on forage crops, and they were talking about these plants like sorghum Sudan grass that would grow, I want to say like 20 tons of biomass per acre, huge quantities of biomass per acre. So if you could knock back an undesirable plant and then establish some of these forage crops, you could outcompete the undesirables with a plant that's going to produce a high level of biomass. And if it's frost sensitive, some of the warmer grasses or plants from the south would die off in our northern winters. And maybe you would have to do that for 2 consecutive years, but you could, essentially you would have this organic strategy to control through competition, plant competition, undesirable plants by using temporary species. And the fourth option is not quite wild speculation, but it's unproven. I had an area on my property. There's a little patch of ferns, and I was raising turkeys then and chickens, and I put the electro net, the portable net fence around that patch of ferns. And my daughters were like, "Oh, Dad, don't do that. You're going to destroy the ferns." And so the first thing that went through my mind was, where did I go wrong that my daughters like these ferns? But then I reassured them. I said, "Honey, don't worry. There's no way we can kill these ferns." Well, mob grazing with poultry resulted in a complete absence of ferns in subsequent years. So, this isn't something that's going to work on 50 acres, but if you have some relatively small areas, it may be that, by essentially trampling and, scratching and doing the things that poultry do may be an option. So don't think you're going to solve big problems with that, but it may be worth considering. So, okay, with that, I want to call this to a close. I'll put my contact information up there. If you'd like a copy of this presentation, please go to the File menu in the upper left-hand corner, Save As Document. And if there are other questions, I'm happy to field those other questions. So go ahead and type them in. I want to thank you all for jumping in and offering some insights into how you would fix some of those problems. So I'll scroll back and see if there's any questions that I missed. Okay, so Martha had a question. Age about a 50 to so so there are the great so we do only have scenario had them be to you know wall or effectiveness. We were currently lost there to have to so in a behavior that we're going to be working with I uh, or or perimeter that intentional right well, should build Russian. Right. 7 p.m. and it's being recorded. Channel 2. That you should just also well, I right right one time off. Uh, so it and we'll see. Well, thank you all a chance to chat and very much for your participation. And let tonight. So I hope you all have a great afternoon. If you're in the woods, safe and think before you act. Have a great